So, good morning ladies and gentlemen. Today we are starting lecture 14 on power flow through a line. Now, let us first do what was that gamma which we used in earlier derivations. If you recall, this propagation constant is a complex number. So, it is a real thing. Alpha is called attenuation constant and the imaginary part beta is called phase constant. Now, if the load impedance is exactly equal to characteristic impedance or surge impedance, then if line is terminated in that load impedance which is equal to its characteristic impedance, the reflected wave voltage wave is 0. This is a very important property, that if you terminate the line in its characteristic impedance or it is also called surge impedance, then what happens? Then such a line is called infinite line. Why it is called infinite line? The receiving end thinks as if the line is continuing. No reflection, absolutely no reflection, and if there is no reflection means it has not terminated. Now, the typical values of characteristic impedance is 400 ohm line value for line, the value for the transmission line rather, and same value is roughly 8 times less for cable. Can you tell me why? Why should there be characteristic impedance so high for a line and so low for cable? Because the definition of characteristic impedance is under root L by C or under root Z by Y. C is very high in case of cables, because it is right there in the ground and the effect of ground is very predominant there. It is very close also, and hence this ZC is always low for cable. Of course, we are assuming 50 hertz frequency. Now, phase angle varies from 0 degree to minus 15 degree for ZC, because it is also a complex quantity. Surges due to switching and lighting is very important. This chapter you might have done, this topic you might have done in your undergraduate. Otherwise, you can revise in the brown book. There is a full fledged chapter on power system transients, right, and you can revise it, review it, read it as and when you get time. Now, I was just repeating ZC is equal to ZS is equal to j omega L over j omega C, j omega gets cancelled. So, we get under root L by C. Now, what is under root L by C? It is a pure resistance. If you carry out a dimensional analysis, which again you might have done in your earlier classes, you will get a unit as an ohm, which is a pure resistance. What is SIL? It is called surge impedance loading. It is a very important parameter. Power delivered by a line to purely resistive load, which is equal to ZC. SIL can be computed by finding out root 3 VR by root 3 400 VR into 1000 kilowatt. This is the power delivered. Now, which on simplification you get 2.5 times VR square kilowatt. This is the formula for calculating SIL once you know the receiving end voltage. Now, lambda is a wavelength is defined by 2 pi by beta. Naturally, the units of wavelength are meters. So, alpha is roughly r by 2 c by l under root and beta is omega l c. So, these three things you can use in numericals. The detailed derivation is given in the book, you can read, but these three quantities are very important. What is the velocity of propagation of wave? V is equal to f lambda. F is frequency, lambda is wavelength, computed like this. Then naturally, the units of velocity is meters per second. If you recall, we did talk about Ferranti effect some time back. What is Ferranti effect and why it is important? It is very rare that receiving end voltage becomes more than sending end. Normally, most of the time, 99% of the time, receiving end voltage is always lower than sending end voltage. At best, it can be equal if you have compensation, but nobody will like to compensate so much that it becomes higher than the sending end. That is never done. At the most, we have flat voltage start. By flat voltage start, I mean the nodes, all node voltages, all bus voltages are roughly same, which is equal to 1 per unit as far as possible. But here is an occasion, here is an instance in which the receiving end no load voltage becomes more than sending end voltage, and this effect is called Ferranti effect. Normally, this is asked in interviews, in viva voce examination, even in examination if there are small questions, 1 mark questions are asked, some examinations like GATE is now purely objective type. So, you must have all appeared in GATE, those of you who got fellowship. Effect of line capacitance, this is because of line capacitance, and that is why in short line there is no Ferranti effect. So, whenever line capacitance is important, that is medium line onwards, especially for a long line where capacitance is really quite predominant, in that case it becomes more visible, and as the line length increases, the effect becomes more pronounced, say 1000 kilometer. The phenomenon is called Ferranti effect. Let us prove this. Here I have written without proof. I mean, you like a nice students may agree whatever I say, but some of you may privately question by how do you say this, can you prove it. So, here is a very small derivation given to show that indeed the receiving end no load voltage is more than sending end. This because this phenomenon is primarily associated with light load conditions or no load conditions. Now, this is a very simple model. There is a capacitance, this is the very first model which we used before T and pi, right, the L model. So, here there is a capacitance at the end of the line, and there is a inductance, and L is the length of the line. So, total inductance is L into L, total capacitance is C into L. This is sending end and this is receiving end. This is VR, this is LL, this is IS and this is IR. Now, because C is less than L, L is the most important parameter in transmission line. That is why L never gets neglected, never. Even if it is a 1 foot line, there will be L, smallest possible line. So, omega LL will be much less than 1 over omega CL, all right. What is IS? JVS into omega CL, all right. So, VR is Vs minus the drop in the inductance. Drop is Is into the impedance, which in this case is purely inductive reactance, value omega L into L. Now Vs plus, substitute the value of Is from here, you get Vs omega square Cl L square. Take Vs common, 1 plus omega square Cl L square, right. Now still it is not clear whether this is a positive quantity, unless until you show that this is more than 1, sorry, more than 0. How do you say Vr is more than Vs? In order to do that, all of you know that Cl is nothing but not always positive, velocity. What is velocity? V is equal to 1 upon under root Lc. So, this will be 1 upon V squared. So, the all are squared then, and no square quantity in the world can be negative, even if the quantity itself is negative. So, some fellow can say, well, I am not convinced. So, now he is convinced, because we know that V is equal to, ठीक है ना? So, now this is positive, there is no iota of doubt left. So, we have proved in a very small, brief, concise way that Ferranti effect indeed exists, and under that condition Vs becomes less than Vr. That is all is Ferranti effect. So, if a small question comes, explain Ferranti effect, show that Vr is more than Vs. So, this is what you have to do. There is a complicated proof also given in the book, the exact proof. If you want, you can see that also. I am not sure whether you have studied tuned power lines. Did you? Yeah. So, in case all of you have studied tuned power lines, then you will all recall that these are important in electronics, communication and electronics, which is a number 1 field today, even ahead of computer. Though computer and IT are now again looking back, and they are again coming sort of on top, but they are fluctuating like your sine wave. Who knows after 4 years whether they will remain so, but electronics will always remain in forefront. So, unfortunately, these tuned power lines are not used in power systems, but they are used in electronics. Why? Let us examine that. What is the definition of tuned power line? Anybody? Yeah.
So, receiving end voltage is equal to sending end voltage.
Magnitude.
Magnitude of the
Magnitude word is very, see, each key word is very important. If you miss that word, you will get 0, and do not say, sir, I meant magnitude only. So, you have to be very careful in Viva, because there nobody will give you another chance. In fact, there nobody will let you know whether you are giving correct answer or wrong answer. They may just very good, you will feel, wow, I am getting appreciated. In fact, he is just laughing on your innocence. It is not only voltage, the magnitude of current as well should be equal, because magnitude is equal in normal case anyway, it is supposed to be equal. That is what flat voltage start is all about. You know, the all voltages throughout the system is supposed to be nearly same, because all equipments are rated at a given voltage, but current also same. That makes it a special case, and such a line is called tuned power lines. That means, no voltage drop on load. Such a line is called tuned line. Unfortunately, if you derive such a condition, you get the value of length as 3000 kilometer. Not everywhere it is possible to have transmission line of this length. There are very few countries in the world having their length or breadth more than 3000 kilometers. Leave China and India and former Soviet Union, or even Rus today, Russia is a big country. So, too long, too costly a proposition, even efficiency is a problem. So, it is impractical, uneconomical for power frequency. At power frequency, it is better not to have such tuned power lines. Adapted for telephony, that is what I said, electronics and telecommunication, because they have higher frequency, megahertz, gigahertz. At that point, it is okay. Just as a passing reference, let me tell you, in sea, on ships and airplanes, we have 400 hertz. Even that is not sufficiently high. Why have 400 hertz? Because weight becomes a weighty problem, an important problem. You do not want higher weight on plane. So, the all equipments, all devices, all your even power plant, if you have that will be of 400 hertz. So, that the size is small, the weight is small. Equivalent circuit of long line we had derived last time, if you recall. We did equivalent exact analysis of long line, and we proved the ABCD constants in terms of hyperbolic, sine and cosine. Then we have given two alternate ways of computing ABCD constants, and those formulas can be used. However, some people still want that I want a equivalent T circuit, I want equivalent pi circuit even for a long line. So, this can be derived, but I thought since all of you have already done it. So, I just give the final answer for equivalent pi as well as equivalent T, and here it is no longer z and y by 2, but here z dash, and which is equal to z c hyperbolic sine gamma L or z sin gamma L upon gamma L, both are same. Similarly, the shunt branch is equal to 1 over z c hyperbolic tangent gamma L by 2 or y by 2 tangent hyperbolic, of course, gamma L by 2 gamma L by 2, right. You can verify this and see if it is all right. I feel they should be all right. Similarly, in T is z by 2, z dash by 2, z dash by 2 is equal to z 2 hyperbolic tan gamma L by 2 gamma L by 2, and then y dash is y hyperbolic sine gamma L upon gamma L. So, this is equivalent T, this is equivalent pi. There is a problem given in the book where I have asked you to show in tabular form the values of sending end quantities, power factors, currents, voltages for all the models, small line, medium line, T, pi, long line, exact, long line, T, long line, equivalent pi, and you compare how the values vary. So, that problem you please solve, attempt at home. If you have any problem, please let me know. Maybe we will have one tutorial class next week, and in that class we will solve some problems. So, please do bring calculators. Now, we come to the very important topic of power flow through a transmission line, because the whole this exercise is for what? You are generating somewhere, and fortunately and unfortunately load is somewhere else, far off, thousands of kilometers away. You take an example of Uttar Pradesh, UP. Most of the generation in eastern UP, Singrauli, the superthermal power station, but most of the load, the industries are in western UP for various reasons. You can see Haridwar, though of course it is no more in UP, but it says there is industry, there is a BHEL there, then Ghaziabad, Noida, all these things are in the western side, okay, and the generation is on the eastern side. So, you have to flow power through a transmission line from Singrauli to Haridwar, Ghaziabad and Noida, and perhaps neighboring states, if any, who is a power shortage state. Just to study this, we consider a simple two bus system. This is called a simple two bus system. Bus is what? Node. Bus is nothing but node. So, this is number 1, this is number 2. You cannot have a simpler system than this. One bus is no system, that means you generate and use it then and there. So, there is no question of power flow, you generate a power and consume there, right. So, the meaning of power flow only comes if there is a 2 bus system, that is minimum. Maximum can be 1000 bus system. The Indian power system is 1000 bus system. If you at all imagine the national grid, which is yet not in place, but they are only thinking. Generator, some people show this sign, some people do not show. Assuming that now there is hardly any DC generation, it is assumed whenever you write generation, it is AC generation. Only transmission now there is a possibility you may have a HVDC, but generation as well as distribution remains largely AC. There is no chance of DC generation, there is no chance of DC distribution. However, in Calcutta we still have DC lines in the houses. Every house has some part connection AC, part DC. So, something works all the time. Now, this is the line which is symbolized by ABCD. This is VR, 0 degree is the reference, this is the load, this is receiving end power which is received, PR plus JQR, real power, reactive power. This is the sending end power, PS plus JQS. All of you know that PS will not be equal to PR, losses. On the way there are losses. So, PS in all probability, there is no exception here like Ferranti effect, is going to be greater than PR. If you ignore losses, then you will have equal to, but that will be a theoretical case. You cannot ignore losses, however small they may be. Similarly, QS is also going to be greater than QR, and if you want equality, then you will have PS is equal to PR equal to P losses. Similarly, QS is equal to QR equal to plus QL. Reactive power loss, active power loss. PL and QL denote real and reactive power losses respectively.
But there is a possibility of QR greater than PS.
No, not transmitted. That is because of load, that is because of compensation, not inherently because of transmission line. There is bound to be I squared x losses in the line. So, the reactive power which is generated here and pumped at this point, by the time it reaches here has to be less, unless until you have compensation along the route, then you are disturbing the system. System is not left on its own, then you will have, you can have anything. It depends on how much power you are pumping in midstream, or 1/3 of the point or 2/3 of the point, that is a separate issue. Otherwise, I think so that QS is always bound to be more than QL. Do you agree? So, this is a 2 bus system. Delta is a very important parameter, it is called torque angle or load angle. We have already talked about delta earlier on. In fact, we have drawn a phasor diagram also with a, if you recall chapter 4, the salient pole synchronous machine and non salient pole, that is cylindrical rotor machine and so on. SR is PR plus JQR is equal to VR IR star, SS is PS plus JQS VS into IS star. Star is conjugate. Any complex variable will have a conjugate. Suppose the complex variable is A plus JB, and if you take a conjugate of this, it will be A minus JB, but if you have minus here, it will become plus here. This you must have studied in your mathematics courses. If you recall your old equation, which is very important equation, I will rewrite here Vs Is A B C D Vr Ir. Find out Ir. What will be Ir? Vs is equal to AVr plus BIR. Now, take the other R in the other side, divide by B, you get IR. Is this equation clear to all of you? Is there anybody sitting here who is not clear about how this equation has come? Just come from here. Similarly, IS. IS is one minute. This has to be IR.
Sir, it is all right. IR has been replaced from our. It will come to.
It is D B here minus 1 minute. I think we are doing some jugglery and then only it will come. It won't be that easy. So, it will come, but you have to do certain mathematical manipulation. Anyway, A, B, C, D are also complex variables, as I told you earlier several times. A is roughly 1, the magnitude, alpha is roughly close to 0 degree or 5 degree, B is an impedance, beta is close to 90 degree, and D and A are roughly same. All right. So, this IR and IS, now you substitute magnitude and angles. So, you will get 1 by B magnitude, Vs magnitude, delta minus beta, because this is delta and this is beta. So, where beta when goes upstairs becomes minus. Similarly, minus A by B, Vr, A is alpha, B is beta. So, alpha minus beta. Is D by B, Vs alpha plus delta minus beta minus 1 by B, Vr beta is only minus beta, because 0 minus beta is minus beta. Substituting for IR, we get in SR. Yes. So, you get this big equation, this I will just leave it here for 2 minutes, so that you can go through the various steps. If there anything is not clear, please let me know. Is it okay? Similarly, if parallelly or similarly, you find out SS, that is sending end complex power. These two equations give the 3-phase MVA if Vs and Vr are expressed in kV line. All right, that can be verified very easily. But they are very complicated equations. Who will remember such complex, or who will derive it in the exam? Very complicated. Why not make it bit simple? So, what do we do? We separate real and reactive power. Okay, imaginary, real and reactive powers, so that we get our old friends cosine and sine back. So, PR is Vs Vr by B cosine beta minus delta minus A by B Vr square cosine beta minus alpha, and QR is Vs Vr upon B sine beta minus delta minus A by B VR square sine, so will be PS and QS. I will leave for just 2 minutes to verify, so that any one of you wants to verify, wishes to verify these equations can do so in 2 minutes time. We have not done anything, we have just separated real and imaginary parts. They are still very complicated. I mean, it is very difficult to remember them. So, why not do something and make them further simple? Before we do that, I want to ask you one question. Our main emphasis is on receiving end quantities. We are not much bothered what is happening in Singrauli. That is why it is in jungle, because the policy of the government is to have power plants near the pit head, coal mine, so that you do not have to transmit or transfer or transport coal, which is not easy. Then you have to request railways, you have to request coal minister and so on. So, it is better to have power plant right there. So, at least railways are not involved, just purchase the coal and start power generation. So, I am not much worried about sending end power and sending end reactive power. I am worried, but not much worried. Like if you get a headache, you are not that much worried, but if something happens more serious, immediately you go to the doctor. Headache you can tolerate, you can take aspirin or whatever. So, I want to know what is the maximum receiving end power. My aim is to evacuate as much power from Singrauli as I can, so that I can take it to Ghaziabad, Faridabad, Noida, Haridwar or any load, anybody who is paying me money. Now, it is a market driven economy. The transmission line may be owned by somebody, but you can book like you used to book computer center once upon a time when PCs were not there. Every one of us who are doing PhDs or whatever, the students, they have to go and write. Even now, I think same thing must be happening. Those who go and work in the computer center, booking, okay, I will come from 10 to 11. Is it happening that way, or there is nobody there? All field is wide open, anybody can go and work. Anyway, there was a time when you have to wait and you have to book timing on mainframe computer. Similarly, I am now interested in what maximum receiving end real power I can get, more emphasis on real power. So, I am interested in finding out the condition for PR max, and our teachers have told us in earlier classes that how do you maximize? By maximizing, or very simple, the first order derivative with respect to the control variable should be 0. So, what is the control variable here? All are fixed, line is fixed, B is fixed, beta is fixed, once line is already let. Vs, Vr normally we fix at 1 per unit. So, they are not variable. Then what is the variable here? Delta. Delta is the only fellow whom you can change, rest of them are fixed more or less. So, delta is the only variable. If I carry out this exercise, the result is, note, PR is maximum at delta is equal to not 90 beta, there is no 90 here, 90 will come after some time at 11:55 and now it is 11:43, 90 will come after some time. So, today just now it is delta is equal to beta. So, if I ask you a question, derive the condition for receiving maximum real power at the receiving end, this is the condition, and you have to come up to this point, such that the value of PR max will be this, because this initial cosine 0 is 1. If you put this value here, what is this? Is it okay?
No, sir.
Not this. This is next. This is given here. You come here, and this beta is equal to delta will make it 0. I do not want to write 0 here, it will be wrong. And then this becomes 1. So, this is what is happening here, Vs Vr by B minus A Vr square B cosine beta minus alpha. Corresponding QR at maximum PR is this, because you can use the same condition here, because if real power changes, reactive power also changes. They are co-travelers. He is sitting on the pillion, so he can't go in opposite direction. He has to be with the driver. So, QR is this value, and notice this sign. Thus, the load must draw this much negative, that is leading MVAR to receive the maximum real power. So, the question can further continue, also find the reactive power received at this condition. So, you continue, marks also will be more. Now, we have to respect what this little girl said about 90 degrees. So, let us go towards that slowly but surely. Consider a short line, because most of the countries are small, most of the states. Now, we are going towards distributed power or dispersed power, which is given in this book in a big way. The market, the privatization, the reforms. So, now we are no more getting power from DESU or DVB, now we are getting for BSNL, Tata Power. So, that is all given here, the whole thing is changed now. So, I am not interested in long lines anymore, shorter lines, shorter systems, smaller generators, right. So, short line has assumed more importance than merely academic importance. The real life lines are also now shorter. So much so, we want to get rid of transmission as much as possible. You generate and use it then and there. That is the called distributed power or dispersed power, which I did earlier in the class. Naturally, A and D will be highly simplified 10 degree, B and Z will be impedance with angle theta, and now this PR, QR, PS, QS are changed to thetas and no more betas now, Z, and I will give you 2 minutes to see whether you arrive at this point. Naturally, if you maximize this, the condition will be delta should be equal to theta, not yet 90. This is second step, where beta has taken given way to theta. It may also happen for a short line, derive the condition, then for God's sake do not derive that condition and then say beta now gets replaced by theta, same thing as I told you earlier. So, then you have to derive from those equations with short line. As I was talking to you, now the condition for maximum receiving end power is delta is equal to theta, and so PR max is this, where cosine theta is R by Z. This is the triangle. Transmission angle. This triangle is not to the size, not to the scale. Normally, R is very small to X. So, this will be this and goes out of the paper. So, I have drawn like this, and theta is therefore 90 degrees. The theta, as you can see from this triangle, may look like 60 or 70, but indeed it is roughly 90 or 89 or 81 or something like that. So, the value of PR max is this, where theta is tan inverse x by r, same theta drawn in this triangle, roughly 90 degrees, as I said. Why? Because r is very small as compared to x. In fact, r by x is roughly 1 by 10. And if R becomes close to x or more than x, what do you call such power systems? There are instances where R is as good as x or more than x even. Huh? No, no, not distribution. See, if you don't know the answer, don't give the wrong answer. That gives still lower marks in an interview. Such systems are called ill-conditioned power systems, like a bad behavior. The boy who gets spoiled, who gets pampered, he goes out in the night time where he is supposed to go in the daytime. Similarly, this power system behaves in a erratic manner to which it is not supposed to behave. And such, if somebody asks you what is ill-conditioned power systems, this is one property of ill-conditioned power system, that resistance becomes more predominant. This is realistic system, don't think it is only fiction. When it happens, see the index, ill-conditioned system, read the book. I want you to cultivate the habit of reading various books, so that you gain knowledge. Classes you can't get all the things, because the time is limited, 60 minutes, but you have to supplement at least in a graduate level. You must have to read journals, not only books, you have to read journals, the papers, institutional engineers, IEEE, IEEE, etc., etc. If theta is 90 degree, then what happens? Then PR becomes our good old friend Vs Vr upon x sin delta, and now if you maximize PR, delta becomes 90, what this young lady was saying. So, we have reached 90 finally, and for this QR is Vs Vr x cosine delta minus Vr squared by x. Some fanatics, some people will not still be satisfied, they want everything very simplified. So, if you want to further simplify these equations, at least QR, you can't simplify PR anymore. PR cannot be further simplified, irreducible, but QR can be. How? Delta is very small in power system. If you recall this power angle curve, we normally operate on this region, linear region, that is up to 30 degree. So, 30 degree delta is small, okay, and hence cosine delta is roughly 1, cosine 0 is 1, and slight deviation from 0 will continue to be nearly 1. So, if you put 1 here, what you will get? Vr by x, Vs minus Vr, okay. And what is this quantity? Vs minus Vr, difference, drop, voltage drop. So, I can call delta V. Can you reduce it further? No. If you reduce further, you go back home, leave your MTech. So, this is the minimum simplest formula anybody in the world can achieve. So far, nothing further. So, QR is equal to Vr upon x into delta V. This is the simplest formula for QR, and simplest formula for PR is this, and this should be CTM, commit to memory, along with this, of course, these three formulas. What are the conclusions? Whatever we have done today, what are the conclusions? For resistance nearly 0, PR is proportional to sin delta. Vs Vr by x is anyway constant, given. This quantity is known, this quantity is known, this is known. Once line is built, x is known, and Vr and Vs are roughly same, fixed. So, only variable is sin delta. That is what I am writing here, that when R is low or 0, PR is directly proportional to sin delta. And if some more fellow who is interested in getting further simplification, this becomes proportional to delta itself for small delta, because when delta is 0, sin delta is also 0, right. So, you can this sin delta is roughly equal to delta for small delta. Like for cos delta it was 1, for sin delta it is delta itself. And QR becomes directly proportional to the deviation, because other things are constant there also. Other thing is what? VR and X. VR is also known constant. That is what your job is, to keep it constant. If it is not, that is why you spend lot of money in UPS and this what you call voltage stabilizer. For anything you purchase in India, you need voltage stabilizer to stabilize the voltage to a constant quantity. But I am more interested in PR, as I told you, continue to tell you since the very first lecture. Whole idea is to reach power, should reach the consumer, the customer, the industry. So, I want to maximize that further. Of course, delta is 90 degree, agreed, but whatever is left I want to still maximize. Like a good businessman, I want to maximize my profits. How do I do that? Increase Vs and Vr as much as you can, but there are physical limitations. You can't make it 1 lakh volts or 1 crore volts. So, there is a limit of 800 kV, 765 kV or whatever, in the world 1300 kV. So, after exhausting that avenue, the next is to reduce X. How do you reduce X when the transmission line is already built? Before building, yes, bundle conductors, this, aluminum, copper, ACSR, whatever you can do. But having built, having purchased car, Alto or whatever, then you can only play with that car only. You can't say I need Mercedes. You are stuck with that car. So, once the line is built, then only manipulation possible is with X. That is all built. You can add, of course, but that is one time solution. After adding 1 line, 2 line, 3 line, then what next? Next is to reduce X, and that is what is the topic of compensation. Add series capacitance in line. How much, where, what quantity is the fresh chapter added, compensation. So, you have to read that. If time permits, we will do it, otherwise we will be happy with whatever we are able to do it. Of course, at a price. Whatever you achieve in life is at a price. As they say, the higher you go, you feel more and more tension. Your hair may go, you may become, sitting at the chair, become fat or whatever, some diabetes or blood pressure or something, So, everything is at a price. What is the price here? Increase the severity of line over voltages under switching conditions, because you have to bring in and out capacitance with switching, and switching transients, again same chapter 13 or whatever it is in that brown book, power system transients. So, you have to read that switching transients are more serious than lightning transients nowadays. So, this or resonance, sub resonance, these are the few problems associated with series capacitances. So, I think we will finish it today. Any questions, please? Whatever we have done today.
Surge impedance loading.
See, loading depends on too many things. There is now voltage stability, there is a angle stability, there is a thermal equilibrium, then there is a surge impedance loading. So, it depends on what is your design objective. Depending on that, you will decide. The bottom line is, I want as much power transmitted as possible, subject to all these constraints.
So, my question is, Ferranti effect can be related to surge impedance loading. Means during the surge impedance loading, sending end voltage is equal to receiving end voltage, but while no load or light load conditions, surge impedance loading is less. So
That is all right. That's, you are explaining the Ferranti effect.
So is it all right?
No, that you have to read and then come back and tell me. You can't explain Ferranti effect using this.
No.
No, Ferranti effect is because of capacitances. This is nothing to do with surge impedance loading. Is not a normal thing. Nobody will terminate the load. Load can vary. Load is a real naughty fellow. Is a random variable. You can't make it load equivalent
If the loading is
to.
less than the
It's only
surge
theoretical
impedance
concept.
loading,
Surge impedance loading is a theoretical concept.
For example,
Well, the thermal is real thing. There should be temperature rise should be within a limit. You can't just go on increasing the heat. Yes, anybody else?
Sir,
Yeah,
the phase angle of characteristic impedance is 0 to minus 15 degrees.
yeah, that's right.
What does it mean, sir? That means actually the same impedance will be there.
No, it varies means it
Load
depends
and
on the line. It can be 0, it is very small.
Yeah.
The value of alpha is very small. It varies around 0 degree or less than 0. That's all it means. So when you solve the numericals, you will get the exact values and you will have a feel of it. When you solve those numericals, right, then you will have the feel of those values. Alright? Okay then, next.